Properties of square numbers. This module will explain the properties of square numbers. Property 1. A number having 2, 3, 7 or 8 at units place is never a perfect square. Property 2. The number of zeros at the end of a perfect square is always even. Example: 100, 400, 6250000. Property 3. Squares of even numbers are always even numbers and squares of odd numbers are always odd numbers. Example: number 9, square 81. Number 10, square 100. Number 11, square 121. Number 12, square 144. Number 13, square 169. Number 14, square 196. Number 15, square 225. Property 4. The square of a natural number other than 1 is either a multiple of 3 or exceeds a multiple of 3 by 1. Example: 2 square is equal to 4 is equal to 3 into 1 plus 1. 3 square is equal to 9 is equal to 3 into 3 plus 0. 4 square is equal to 16 is equal to 3 into 5 plus 1. 5 square is equal to 25 is equal to 3 into 8 plus 1. Property 5. The square of a natural number other than 1 is either a multiple of 4 or exceeds by 1. Example: 2 square is equal to 4 is equal to 4 into 1 plus 0. 3 square is equal to 9 is equal to 4 into 2 plus 1. 4 square is equal to 16 is equal to 4 into 4 plus 0. 5 square is equal to 25 is equal to 4 into 6 plus 1. Property 6. The units digit of the square of a natural number is the units digit of the square of the digit at units place of the given natural number. Property 7. There are no natural numbers p and q such that p square is equal to 2q square. Proof. Case 1. When p and q both are odd. Solution. P and q are both odd is equal to p square and q square are odd is equal to p square is odd and 2q square is even is equal to p square is equal to 2q square is not possible. Case 2. When p is odd and q is even. Solution. P is odd and q is even is equal to p square is odd and q square is even is equal to p square is odd and 2q square is even is equal to p square is equal to 2q square is not possible. Case 3. When p is even and q is odd. Solution. P is even is equal to p contains 2 as a factor is equal to p square contains 2 square is equal to 4 as a factor and q is odd is equal to 2q square contains 2 as the only even factor possible. Thus, p square contains 4 as the smallest even factor and 2q square contains only 2 as the even factor. So, p square is equal to q square is not possible when p is even and q is odd. Case 4. When p and q both are even. Solution. In this case, p and q both are even is equal to p and q both contains 2 as a factor. Let d is equal to HCF of p and q. Then p is equal to d into x and q is equal to d into y for some natural numbers x and y having one common factor other than 1. Now, p square is equal to 2 into q square is equal to d into x whole square is equal to 2 into d into y whole square is equal to d square into x square is equal to 2 into d square into y square is equal to x square is equal to 2 into y square. Since x and y have no common factor other than 1, therefore at least one of them is odd. But this is not possible. Hence, there are no natural numbers p and q such that p square is equal to 2 into q square. Property 8. For every natural number n plus 1 whole square minus n square is equal to n plus 1 plus n. Proof: for any natural number n, we have n plus 1 whole square minus n square is equal to n plus 1 plus n plus n plus 1 minus n is equal to n plus 1 plus n. Example 1. 9 square minus 8 square is equal to 9 plus 8 is equal to 17. 2. 19 square minus 18 square is equal to 19 plus 18 is equal to 37. Property 9. The square of a natural number n is equal to the sum of first n odd natural numbers. For example, 1 square is equal to 1 is equal to sum of first one odd natural number. 2 square is equal to 1 plus 3 is equal to sum of two odd natural numbers. And so on.